Okay, I'm going to go over indications of a chemical reaction. So we just talked about chemical reactions. From now on, instead of writing out reaction, I will be writing RXN, that is the chemistry abbreviation for reaction. So indications of a chemical reaction. Evolution of heat and light and or light. So that would be like something burning. So remember I told you a chemical reaction or a chemical change would be like something burning. So if it emits, that would be another way of saying it, emits heat or light, it is a chemical reaction. The other one would be formation of a gas. Okay, so if it bubbles when you mix the stuff together, if it wasn't bubbling before, then if it's forming bubbles when you pour two substances together, that's going to be an indicator of a chemical reaction. So that doesn't mean that necessarily like soap is making a chemical reaction. It means if you pour two substances together and they start to bubble and release gases, that's a chemical reaction. The most basic description of chemical reaction with the formation of gas bubbles, you've done it, I'm sure, before, where you pour baking soda and vinegar together and it makes it bubble. A lot of people use that with like little volcano projects. So that would show that it is a chemical reaction. It's producing a gas. The last one is probably one that you've not heard of before now. Formation of a precipitate. And a precipitate is just a solid that forms in a solution. So if you pour two liquids together and a solid forms in it, that would be a precipitate, and that would be an indication of a chemical reaction. Okay, so moving on, and we are still reviewing, that's why I'm kind of going through these quickly. I mentioned pure substance earlier. So a pure substance doesn't have anything mixed with it. Pure substance can be an element or a compound. So an element remembers anything from the periodic table, or compound. So like you can have pure water, as long as it doesn't have anything else in it. Does that mean that the water that comes out of the faucet or out of your well is pure? No, it's got stuff dissolved in it. Pure water would be distilled water because it's got all the impurities taken out of it. Then we have mixtures. Okay, a mixture is just two or more substances physically combined. So remember I told you that like compounds are chemically combined. Elements are chemically combined. You can't really separate them out easily. Mixtures you can separate out easier. So you have two or more substances physically combined. That means you just mix them up together. The mixture can be homogeneous or heterogeneous. And I know that you've heard these roots before, homo and hetero. Homo means same. Hetero means different. So if you just break it down like that, then you can always tell what it is. Homo, the one that says homogeneous, means same, so it looks the same. So if you look at it, you can't see the different particles. You can't tell if one is a gas and the other gas from the first one. You can't tell that in milk. You can't tell the water from the fats, from the proteins. It all looks the same. So homogeneous mixtures, I'll just go to air is one, milk is another one. Those are probably your most common ones. Salt water would be another one, sugar water. So if you look at it, you can't see the oxygen, nitrogen, carbon dioxide. If you look at this, you can't see the fat, the water, the proteins. If you look at this, you can't tell where the salt is and where the water is. So it looks the same throughout it. Heterogeneous looks different. So you can pick out the different pieces of it. This would be like if you mix salt and pepper. Salt and pepper. It could be oil and water. So you can look at it and see the salt, you can see the pepper, you can look at it, you can see the oil, you can see the water. If you're mixing up chocolate chip cookies, you can tell the chocolate chips from the batter. So that would be a heterogeneous mixture. You can tell the difference between them.